Hello everyone, welcome to Physics Infinity channel. In this video lecture, I am going to discuss the nodal analysis method to find the currents in the different branches of an electrical circuit. Of course, there are the famous Kirchhoff rules that can be applied to find the currents, but then we all know that the applications of Kirchhoff rules is rather time consuming. In the nodal analysis, to learn about the nodal analysis, I will take up a particular example, a particular circuit, and I will show to you that how we can find, using nodal analysis, the currents in the different branches of this circuit. The circuit is, here it is. Well, this is the circuit. If you look at A, B, C, D, and there is EF. 20 ohm, 15 ohm and 10 ohm are connected like this. There is a voltage generator or a battery, you can say, of 100 volts here. The upper plus is connected to A and the lower is connected to the points E. Similarly, 80 volt, its minus terminal is connected to D and the positive terminal is connected to F. So here it is, the circuit is complete. We have to find the currents in the different resistors, 20 ohm, 10 ohm, 15 ohm, 10 ohm and 10 ohm. Now to do that, we make use of the nodal analysis, and in the nodal analysis we take a reference node, and the reference node we give a typical value, say 0 volt, and then in the circuit we'll identify the fixed nodes and the independent nodes. For example, in this circuit I have assumed E and F. Well, that's one line, they are at 0 volt. So the node E and the node F are at 0 volt. Then A and D become fixed nodes. So A will be 100 volts and D will be minus 80 volt. B and C are independent nodes. Their values are not known. If we are able to find the potentials of B and C, then we know the current in every branch of the circuit, in every resistor of the circuit. Well, that is what we are going to do in this analysis. So let's start. I have already identified the nodes. I have taken the reference nodes. I have taken the fixed nodes A and D, and I have taken the independent nodes B and C. Okay. At B, we will apply the Kirchhoff rule 1, the current rule. Let's say the current in 20 ohm is I1, the current in this 10 ohm is I2, and the current in 15 ohm is I3. Similarly, at the node C, I3 enters the node, I4 leaves the node, I5 leaves the node. So I5 is through 10 ohm and I4 also is through 10 ohm. Let's apply the KCL or the Kirchhoff rule 1 at the node B. I have I2 plus I3 equal to I1. Standard procedure. The current entering the junction is equal to the currents leaving the junction. So I2 plus I3 equal to I1. Now what is I2? VB minus 0 upon 10 resistance plus I3 VB minus VC, both VB and VC are unknown, divided by 15 resistance is equal to 100 minus VB upon 20, that is I1. I adjust the equation. I frame the first equation, 13 VB minus 4C equal to 300. Keep it one equation number 1. I have two variables, VB and VC, so I must need another equation to know the value of VB and VC, and for that, of course, I will use the KCL, the Kirchhoff's current rule law at C. Now at C, if you can see very well that I3 entering the node C, I5 leaving, I4 leaving. So I4 plus I5 equal to I3. Now what is I4? VC minus 0 upon resistance 10 plus, what is I5? VC minus minus 80. VC minus minus 80 will become VC plus 80 divided by 10 is equal to VB minus VC upon 15. Adjust, I get the second equation, VB minus 4VC equal to 120. Two equations, two variables, easy job. I find the value of VB and VC. Well, we get VB equal to 15 volt. Please note, VB equal to 15 volt and VC equal to minus 26.25 volt. Minus 26.25 node. Now, I know the values of all the potential at all the nodes. VA, VB, VC, VD, VE and VF anyway are taken as 0 volt. Alright, now let me find I1. So I1 will be what? 100 minus VB divided by 20. I lift VB from there, so it is 100 minus 15 by 20, that is 4.25 ampere. I get I2, VB minus 0 upon 10, that is 15 upon 10, 1.5 ampere. So easy. I find I3, there is I3, so VB minus VC, VB 15, VC minus 26.5, that adds up, it becomes 15 plus 26.5 divided by 15, that is 2.75 ampere. Alright, I4, VC minus 0 divided by 10, now VC is minus 26.25 divided by 10, I get minus 2.625. The minus sign tells you that the current I4, here is I4, is actually moving F to C. I had assumed it is moving C to F, well that was assumed algebraically, but the minus sign tells you I4 actually is flowing F to C. Then I5, VC minus 80, VC minus 80 divided by 10, I saw that is minus 26.25 plus 80 divided by 10, that gives you 5.375 ampere. So we have found the currents in all the branches making use of the nodal analysis. Straight away I had taken the case of two independent nodes. Of course, if there were, I could have taken a problem with one node, but that would have been too easy. If you have understood this, obviously all other such questions making use of the nodal analysis you can easily solve. Thank you very much for watching my video.
If you love the video and want me to make more useful videos for you, subscribe my channel and hit the bell icon to stay updated.